Okay, guys, welcome back. Hope you guys had a nice spring break. So we really only have 2 weeks of real class left. But just wanted to kind of recap some of the things before break. I know a lot of us were not here on Friday, so tomorrow I want to check students' homework for students who weren't here. So I need to check page 13 through 18 odds from packet 2B. Oh, sorry, page 6 through 10, all on packet 3. And then in class, we did page 12 to 14 on Friday. So I need to check both of these if you weren't here on Friday. And then today, we're just going to continue with packet 3, working towards finishing packet 3. I'll send out a reminder this afternoon as well.
You have to guess. Like, what the students say.
Yeah.
So why would you go back and make you a slide?
Okay, so today we're going to pick up on page 15, and we're just going to be working with differential equations. We did some Riemann sums already. So our quiz coming up this Thursday. This Thursday, yeah. So we have it'll be 2 FRQs. One page will be a Riemann sums FRQ, and the second page will be the differential equation FRQ. This is going to be minor grade, but this will be 50 points, and the other 50 points will come from packet 3. Okay. Next week, we're going to have a multiple choice test split up Tuesday and Friday. So next Tuesday will be 8 multiple choice questions. This will be non-calculator, and this will be worth 25 points. And then, so we'll spend Friday and Monday reviewing, going through packet 4, just over first semester content, so we can see, get an idea of what those problems could look like. And then, so that'll be a Tuesday. And then Wednesday, Thursday, we'll practice through second semester content, integral, use substitution, all those topics. And those will be spring semester topics. And multiple choice test will be for second semester topics will be next Friday, 8 multiple choice questions as well. This is with calculator. So this is 25 points, this is 25 points, add that together, that's 50 points. And then the other 50 points is coming from packet 4. Good. Okay, so these are the only remaining in-class assessments that we have. Quiz Thursday, and then next Tuesday, Friday, test grade. After that, we're just going to be working on packets 5 and 6. Packet 5 is just a collection of FRQs. Packet 6 is multiple choice tests, and those are just going to be completion grade. We'll be working through it in class, but then those are EOC week and AP exam week 1. So students will be in and out of the classroom, but you'll be able to have everything that you need to work at your own pace if you're not here as well.
EOCs are first week of May.
Sorry, so EOC is going to be the last week of April, and then the first week of May is AP exams, and our AP exam is the first that Monday of that second week. All right, so this week and next week are really the last 2 weeks of normal bell schedule. After that, it's going to be EOC and AP exams. Okay. Any questions? I finished grading your FRQ test, so I will put them in the grade book today, and I'll hand them back to you tomorrow.
Do they look good?
Yeah, look pretty good.
Okay.
All right, so page 15. right, consider differential equation dy dx equals 3 minus y cosine x. Let f of x be the particular solution to the differential equation. So we know that this is a slope field for that differential equation. Part A, a portion of the slope field for a differential equation is given. Sketch the solution curve through the point 0, 1. So really, this is pretty easy because all we're doing is just follow the flow of the graph. And we just have to make sure that the graph goes through 0, 1. So if we just follow the flow of the graph of going through that point, we can kind of see how our graph is moving and curved. So again, this just emphasizes the fact that a slope field gives us an idea what the function would look like, even though all we're dealing with is we're just looking at the derivative graph, and we're just looking at all these slope fields that make up the derivative graph. Okay, I'm going to put part B up here so that we can save part C for the bottom of the page where majority of our solving different equation is going to come from. So part B says, write an equation for the line tangent to the solution curve at 0, 1. Use the equation to approximate f of 0.2. So this is just linear approximation. We're going to gather our order pair, our slope, build our point slope form, and then put the decimal in. Okay, so let's create our tangent line equation first. Or let's gather the data for tangent line equation, which we need the order pair. And the order pair is provided for us, 0, 1. And then what can we use to find the slope? Good, dy dx, that's our slope formula, that's our derivative. So we can just take the order pair, plug into the derivative, whatever value we get, that's our slope value. This is FRQ number 5 from 2014. So this is non-calculated. Yeah. Which means now on the quiz Thursday, you'll get to use your calculator, but I think it's good for us to kind of get an idea, how do we answer the question without a calculator? And the way that you do it is you would leave your answer unsimplified. Don't try to add any of the fractions together or decimals together. Just leave it all unsimplified, and that will be sufficient. In this case, though, we do want to get this down to a numeric value. So cosine of 0 is 1, 1 times 2 is 2. So our order pair is 0, 1, our slope is 2, point slope form. Okay, so there's our tangent line equation. And then now our last part is the linear approximation. So we're just going to plug 0.2 in for x. And that's all we need to do. This is sufficient to earn full credit. Part C, now we're solving the differential equation. So we're going to set up our derivative, get fractions to line up, cross multiply, and go through our full process there. And if they give you a set of parentheses, you want to hold on to those sets of parentheses because they're trying to help you organize your variables. They're trying to help you organize your variables. All right, so I'm going to first start off by putting a 1 in the denominator so I can line up my diagonals and cross multiply. Again, cross multiplying is not going to separate my variables completely, potentially, but it will get my dy and dx lined up where I want them to be. Right? My dy and dx's are in their preferred locations. So now we have to consider, okay, do we have full separation variables? Is there anything that is out of place? 3 minus y. So we're going to move that by dividing it over. That's the only thing, right? So we just divide that over. And then now that we have full separation variables, we can think about our integral steps. Okay. See, the right side is pretty straightforward. What's the integral of cosine? Positive sign. Okay, so no need for u substitution. It's just a straight integral process. So we'll save that for our next step here. But what is required on the left side here? Yeah, we do need to go through a little bit of u substitution. What's our u value? 3 minus y, and it'll end up being what rule down the road? 1 over u, which is natural log, right? Okay, so, but we do want to go through u substitution because there is going to be something that's going to come out of that derivative. What's going to be the derivative of 3 minus y? -1. Yeah, so we got to keep track of that -1. That -1 will have to we would hold on to that derivative as part of our u substitution step. Okay, so 1 over u times -1 du. So we do have to keep track of the fact that there is a -1 that's going to have to be a leftover out of my u substitution process. Okay, so natural log of u, replace the u back in terms of y. So now everything is in, now I have everything up at the function level. And the right side, we talked about cosine just becoming sine. No need for u substitution there. All right, so if we're here, then we've earned a good chunk of our points because we separated the variables. We've taken care of all the calculus process. There's only 2 things left to do. We got to solve for y. We got to solve for c. It doesn't matter which order you do them in, but the way I'm doing it is I'm going to be working on that left side. And if I can find a spot for me to solve for c, I'll kind of pause and solve for c. But if I can't find an easy spot to solve for c, then I'm just going to wait till the end to solve for c. Yeah.
How we get from du dy equals -1 to dy is -1?
Yeah, I skipped a step here. So dy equals, I got -1 dy equals du. I divided both sides by -1, but I prefer to put a -1 in the numerator, so I put a -1 du. Yeah. Okay, so I'm going to work on cleaning up that left side. I do want to involve raising both sides with e as the base, but that negative is kind of getting in the way. So I'm going to move that negative over to the right side. So I get a cleaner relationship when I raise both sides with e as the base. And so again, all the calculus is done. Now we're just doing some algebraic cleanup. All right. I want to get down to that y variable, but that natural log is in the way. I'm going to raise both sides, e as the base. That should clean up that e and natural log. I know I can break this up into the product of 2 bases. I know e to the c is just what? The c, I can pull that in front. I can drop the absolute value. The plus or minus will get moved into that c. Okay. So I just haven't found an easy spot for me to solve for C. So I'm really just going to wait till the end to solve for C here. It's going to get Y by itself. So really, I've just got Y by itself. And now that I have Y by itself, I'll focus on solving for C. Okay, so 0 in for X, 1 in for Y. Once I have that C value found, I can update this and turn this from a general to a specific solution. Sine of 0 is 0, e to the 0 is 1. And C is equal to 2. So I'm just going to update that C value with what I just found. There's my specific solution. Page 16. So this one, we do have to create a slope field, but thankfully it's only a few points. So again, you're never going to be asked to create a slope field across hundreds of points. It's just going to be at, at most 6 to 10 points. So start off by doing that. Identify the location of your order pairs, plug them into the derivative, and then if you get a positive number, you're just going to do a positive slope segment. If you get a negative number, you'll do a negative slope segment. If you get a 0, you'll do a 0, a horizontal line segment. What if you get like a 10 over 0? Nothing. Yeah, leave it blank. We don't do vertical lines. We just leave it blank. So here I'm going to start off at 0, 2, 0 in for X, 2 in for Y. That's going to give me a negative number. Um, 0, 1. 1 in for Y, 0 in for X. I get a negative, yeah. 0, 0. 0 over -1, that's 0. That's a real number. We do need to do a horizontal line there. Plug in 2. 2, 2. I get 4 over 1, which is 3. Sorry, 4 over 1 is 4. Positive slope. Plug in 2, 1. Two in for X, 1 in for Y. Positive value. 2 in for X, 0 in for Y. 0 horizontal. Part B, solve the differential equation. You have your order pair, find your slope, point slope form, and then decimal value. So once I've built my tangent line equation, I'm ready to do my linear approximation. 2.1 goes in for x. Again, this is meant to be non-calculator. This, as you can see, number 4. So 4 through 6 are non-calculator. You can leave your answer unsimplified. Okay. Moving on to solving differential equation, cross multiply, separate variables. Okay, have my dy dx's in my preferred spots. Okay, do we have full separation variables yet? Not yet. Okay, so what needs to move? Yeah, they're both going to have to move to the denominator of the other side. So I like to do them both at once. Okay, just move them both into their preferred locations, and then we can get full separation variables. Okay, let me just briefly talk about the right side here. What would you do on the right side? Okay, u substitution, u value being x minus 1. The left side, what would you do? Move it up. Is there a need for u substitution here? No. So if it's a single variable, you never have to go through u substitution. The most you have to do is, move it to the proper location. We don't leave this in the denominator. This is not a natural log. If it was dy over y, then that'll be a natural log. But if it's any other power, we got to move it up. We'll go through power rule. So I see some students going through u substitution. It's not wrong, but you're just doing additional steps that's not needed. Okay, so no need for u substitution if it's a single variable. More than one variable, then I will go through u substitution. Okay, so I'm just doing all the setup here for the left and right side. Okay, so y to the -2, what does that become? What's the integral? Yeah, y to -1 over -1. I'll clean that up later. The right side, we know u substitution. It'll end up being 1 over u du, which is natural log. Natural log absolute value of u. Replace the u back in terms of x.
The dx go, where it's like dx over x minus 1 and over linear u values of x minus 1.
Yeah, so this ends up being du over u or 1 over u du. Yeah, you can write it like this, or you can push it out to the right side.
But how are we getting rid of the dx?
Oh, dx equals du,
Oh, okay.
because derivative is just 1, so when I cross multiply.
First. Okay.
Okay, let's do some cleanup here. So I want to solve for y, but this is a little bit strange because I do want to flip both the numerator and denominator, but I find that this relatively easy spot for me to solve for C because I don't have a whole lot of negative exponents here. So in my mind, I'm just going to get that C value out of the way. So I'll take my order pair 2, 3, and just see if I can get that C value just taken care of. So the nice thing here is natural log of 2 minus 1 is just natural log of 1. Natural log of 1 is 0. So my C is just going to be negative. Okay, I'm going to go back to my equation here. I'm going to move that negative over because I do want to now work on cleaning up that left side. So I get a positive 1 over y is equal to negative natural log of x minus 1 plus third. Now, I see that to get y by itself, I just need to flip that numerator and denominator, right? But if I flip that numerator and denominator, that means I need to flip this side as well. So this is what we cannot do, okay? It feels like this would work, but if I flip this left side here, that becomes y over 1. You may be thinking, okay, I'll just flip these two individually and make it 1 over negative natural log of x minus 1 plus 3 over 1, right? I just flip everything here, but this is connected by plus signs, so we can't flip these individually. So we can't quite do it this way. Right? What we need to do is, if we want to flip that left side, this would become y, but this whole thing gets flipped to the denominator. I know it looks messy, but we don't have to worry about cleaning anything up. As long as we get y by itself, whatever it looks like on the right side, they'll give you full credit. So no need to do common denominator, no need to merge fractions. But because of that plus sign, we can't individually flip and still keep the same value. We have to treat this like the numerator and put all this in the denominator. Okay, page 17. All right, large vat is initially filled with saltwater solution. A solution with a higher concentration of salt flows in the vat, and the solution flows out of the vat at the same rate. The number of pounds of salt is modeled by a differential equation, dA dt equals 6 minus 0.02a. At time equals 10 minutes, the vat contains 50 pounds of salt. Write an equation for the line tangent to the graph of A at t equals 10. So normally we think of tangent line equation in terms of y and x's. But we have to adapt our equation into the variables that is presented here. So instead of x and y, we're going to use t for time and a for the amount of, so t will be your x, and then your a will be your y. So we can think of it this way. We can say a minus a sub 1 is equal to m times t minus t sub 1. Okay, so let's find our order pair. Ten minutes, 50 pounds of salt. Slope. Six minus 0.02 times 50, that's my A value. And this is with calculator, so I'm just going to put this in and I'm going to get a 5 for my DADT. I have my order pair, I have my slope. Put it into my linear equation. But just have to adapt in terms of A and T. And now linear approximation. Use tangent line approximation to find the amount of salt at 12 minutes. So we'll plug 12 in for T. Part B showed that A of T satisfies the differential equation dA/dt with initial conditions 1050. So we basically have to find that these are the same, or they represent the same thing. So let's just find A prime, and then let's see if we can get our A prime to look like A prime here. So let's build our A prime from our own derivative rules, and then we'll see if the derivative can somehow match with that. So A prime, let's think about our derivative rules. 300 turns into what? 0, okay. And this is e to the u. What's the derivative of e to the u? Yeah, e to the u times u prime. And my u value is the entire exponent, so the derivative of my exponent is just going to be negative 0.02 because the 0.02 is a constant that goes away, and the linear just becomes the coefficient in front. Okay, so that's my derivative. Let me clean this up here. A prime. Use my calculator. Negative 250 times negative 0.02. That's going to give me 5. Meanwhile, this is already my derivative level. So dA/dt equals 6 minus 0.02. Now my A is this original equation here, right? So if I replace A with this equation, And the hope is that if we clean this up, that this will look like this A prime in terms of T. Distribute the 0.02 through. This times this gives me 6. Negative 0.02 times negative 250 gives me 5. Sixes cancel out, and we get the same looking A prime.
We have to calculate that, right?
Hmm?
Would we have a calculator for this?
Yes, this is calculator, yeah. So we've shown the work to show that these are the same. All right, part C, we're moving into our solving differential equation phase. All right, part C, the flow of solution into the vat is stopped and the solution is drained. The depth of the solution is modeled by the differential equation dH dt equals negative k root h, where h is measured in meters, p is in minutes, and k is a constant. If the depth of the solution is 16 meters at time t equals 0 and 4 meters at time t equals 30, what is h of t in terms of t? So let's just go ahead and start working on separating our variables. Now, you're going to treat k like it's just a number, and we're going to keep that on the right side along with the t. So again, we want to leave that left side as minimal as possible. In this case, if you don't see x's and y's, it'll always be time t and something else. So t is your x, whatever your other variable is, that's kind of like your y. Okay, cross multiply. All right, do we see anything out of place? We already have our dHdt lined up nicely here. The root h, okay. The k is going to stay on the right side. Remember, the k is just like a number, and anything that, like a numeric value, we want to leave on the right side, because the left side, we only want to make it as minimal as possible. We have h's on the left. The right side is in terms of t and everything else. What would you want to do on the left side? Mhm.
1/2.
And rely on what rule? Oh, okay. So we'll make it h to the negative 1/2 dh. And remember, k is the constant, so we're really taking the integral of 1 dt here. It's not going to be k squared over 2. K is not the variable here. The variable is time, and there's no variable t, so it's just a 1 that you're having to worry about. Okay. All right, so now we're ready for our integral process. Power rule on the right, power rule on the left and on the right. K is just a coefficient. What is negative k times integral 1 dt going to turn into? Integral here, what's integral of 1? But we want to use what variable? T, yeah. So t, so what does that become? What's the result of this going to be? That again?
T squared.
Not t squared. 1 becomes t. That k stays as k. So it'll be negative KT plus C. Think of the K as just a number, it's like 3 or 4. It'll just attach itself to the variable. All right, dividing by 1/2 is the same thing as multiplying by 2. Now, what makes this more complicated is we have to not only solve for C, but we also solve for K as well. And we have 2 order pairs. That's going to help us. We know that there's a moment in time when t equals 30 and solution, sorry, 60 meters at time t equals 0. So we'll use that order pair to help us solve for whatever is helpful. So we have order pair. We always want to involve 0 first. 0 is going to be the easier one to involve. So t equals 0, we have 16 meters for our solution for H. This should help us solve for K and get that K out of the way here. So 2 root 16. Root 16 is 4. 2 times 4 is 8. Okay, sorry, this gives us our C value. Okay, so we have our C value. So now let's update the equation and use the other order pair to solve for K. So they also give us an order pair of 4 meters at t equals 30. Get that out of the way as well. -4 divided by -30 is 2 over 15. So I have my K value, I have my C value. I'm just now going to be working on trying to get H by itself. Oops, 8. Now I have my C value. So divide by 2, square both sides. Once I square both sides, then I have my H and I have my solution. Okay, let's start page 18. Our homework is just going to be page 15 through 18, so I think we'll be able to get through most everything in class. Okay, on Saturday before Mother's Day, drugstore has a large selection of greeting cards for sale. Between 0 and 10, the number of cards left on the shelf is changing at a rate of m prime. So we see that at 0 hours, the rate at which card is leaving the shelf is -15 cards per hour, and then -10 cards per hour, -12, -14, -12. Okay, so pretty busy day for all the cars to be sold. So part A says approximate the second derivative, m double prime of 6. Show the calculations that lead to your answer. So basically, we know second derivative given derivative is just slope, right? So we're just going to pick the closest points and do the change in m prime over the change in time. Because m prime is in terms of cars per hour, we know m double prime is going to be cars per hour squared. So using correct units, interpret the meanings. So anytime we're talking about second derivative, we don't want to rely on acceleration, even though acceleration is good for particle motion. We want to say something in terms of the rate is increasing or the rate is decreasing. In this case, the rate is going to be increasing because we get a positive value. So looking for these words here, the rate is increasing, or the rate is decreasing, or the rate is changing. I write an equation for the tangent line. So order pair and slope. Typically, we're used to x's and y's, but we have to adapt to our problem here. It'll usually be, if you don't see x and y, it'll be t and something else. In this case, it's going to be m and t. Write an equation for the line tangent at t equals 7. We have order pair, 7, 44 that we can use. We know the slope is going to be m prime of 7, which is negative 12. And now I'll just put it into our point slope form. And now linear approximation, we just plug 9 in for t. Okay, your homework is just to finish off this page, 15 through 18, and then I also need to check pages 6 through 14 in this packet. So if you weren't here on the Friday before break.
Got it.
No, it doesn't include that. 6 through 10, 12 through 14, and 15 through 18.
Or you're gonna check 6 through 18, just not 11.
Right. Skip 11.